November 12, 1942, Richmond, California. A cargo ship slides down the ways into San Francisco Bay, and the men watching know they've just witnessed something impossible. The SS Robert E. Peary is complete, functional, ready for war. 4 days, 15 hours, and 29 minutes ago, there was nothing but an empty slipway. Now there's a 10,000-ton vessel capable of carrying tanks, ammunition, food, and fuel across an ocean. The German naval intelligence officer who reads this report 3 weeks later will understand immediately what it means. Germany has already lost World War II. They just don't know it yet. This is the story of how a dam builder who'd never constructed a ship became the architect of German defeat, how welding torches proved more powerful than torpedoes, and how American industrial capacity, organized by a man who didn't know the rules, buried the Third Reich under an avalanche of steel faster than any submarine could sink it. The mathematics were brutal, elegant, and absolutely final. In 1940, Henry Kaiser was 58 years old and completely ignorant of shipbuilding. He'd made his fortune moving dirt and pouring concrete. Hoover Dam, Grand Coulee, Bonneville. Massive projects that required organizing thousands of workers, meeting impossible deadlines, and improvising solutions when traditional methods failed. He understood logistics, efficiency, and industrial-scale construction. Ships? He'd probably never been inside a working shipyard in his life. He certainly had never built one. When Britain desperately needed cargo vessels to survive German U-boat attacks, traditional shipbuilders were horrified that Kaiser even bid on the contracts. The established yards had proud histories, stretching back generations. Newport News, Bath Iron Works, New York Shipbuilding. These were craftsmen who'd learned their trade from their fathers. Master riveters who could work in darkness. Welders who knew every metallurgical trick. Foremen who could spot a structural flaw from 50 yards away just by looking at a hull's curve. If you're enjoying this deep dive into the story, hit the subscribe button and let us know in the comments from where in the world you are watching from today. They built ships the way ships had always been built. Slowly, carefully. From the keel upward, adding each section in sequence. Riveting thousands of metal plates together with pneumatic hammers and red-hot steel rivets. Each vessel took months, sometimes nearly a year. A Liberty ship, even using the simplified British design, averaged 230 days from keel to launch at traditional yards. That was simply how long proper shipbuilding required. You couldn't rush maritime construction. Quality took time. The sea punished shortcuts with death. Henry Kaiser looked at those numbers and asked one question. Why? Why does it take 230 days? Why do you need highly skilled craftsmen for every single task? Why can't you break the construction process into simple, repeatable steps that anyone can learn? The shipbuilders laughed. Some openly mocked him. You can't mass-produce ships like automobiles, one executive told him. Ships have to be watertight. They have to survive North Atlantic storms. Stick to your dams, Kaiser. Leave shipbuilding to people who actually know what they're doing. But the U.S. Maritime Commission was desperate. Vice Admiral Emory S. Land, a Navy man with decades of experience, didn't particularly like Kaiser. The man was brash, overconfident, made promises that seemed physically impossible. But Land was also a realist facing catastrophic numbers. German U-boats were sinking Allied merchant ships faster than all existing yards combined could possibly replace them. In 1940 alone, over 1,000 Allied vessels went to the bottom of the Atlantic. In 1941, the losses accelerated. Britain's lifeline was being cut. Traditional shipyards couldn't scale fast enough. They were already overwhelmed with naval contracts for destroyers, battleships, and aircraft carriers. America needed merchant ships by the thousands. Kaiser was offering to build them. Land gave him contracts not because he believed in Kaiser's wild promises, but because America was running out of options. Britain was dying. Without cargo ships, the island nation would starve before American soldiers ever reached European soil. Kaiser was awarded contracts to build shipyards in Richmond, California, Not one shipyard, seven. Seven massive facilities on San Francisco Bay, designed from scratch to operate like nothing the maritime world had ever seen. He hired Albert Kahn, the industrial architect who'd designed Ford's River Rouge plant. "Build me a shipyard that works like an assembly line," Kaiser told him. "I want ships to move through construction the way cars move through a factory." The traditional shipbuilders watched with malicious anticipation. This civilian was about to learn the most expensive lesson in industrial history. Ships weren't automobiles. You couldn't just apply factory logic to centuries of maritime tradition built on hard-won knowledge, paid for in drowned sailors. The sea would expose every shortcut. Welded hulls would crack in rough water under stress no riveted ship would fail to handle. Unskilled workers would make fatal errors. Kaiser's ships would sink. Men would die. The Navy would shut down his fraudulent operation, and the real shipbuilders could get back to doing things the proper way. Except Henry Kaiser didn't know he was supposed to fail. He broke every rule because he didn't know the rules existed. And that ignorance, combined with methodical engineering thinking, was about to change naval warfare forever. Richmond Shipyard No. 2 opened in December 1940. Within weeks, Kaiser had thrown out the traditional shipbuilding manual and replaced it with principles borrowed from dam construction and automobile manufacturing. Instead of building ships from the keel upward in a single dry dock, slowly adding each section in sequence over months, he created a parallel assembly process that would have seemed insane to any experienced naval architect. The hull was divided into prefabricated sections built separately across the massive yard. Bow units, stern assemblies, deck houses, double-bottom sections, engine rooms with machinery already installed. Hundreds of workers welded these enormous sections in separate buildings, working simultaneously on different parts of what would eventually become a single ship. Then, massive cranes, some of the largest in America, specially designed for this purpose, lifted the multi-ton sections and assembled them like puzzle pieces. It was audacious. It was unorthodox. It violated every principle of traditional naval architecture, and the old guard predicted utter disaster. Traditional shipbuilders used riveting exclusively, teams of skilled workers heating rivets to red-hot temperatures, then hammering them into pre-drilled holes with pneumatic guns that shook entire hulls with their pneumatic thunder. It required years of training to rivet properly. You had to know the exact temperature too hot, and the rivet would be brittle, too cold, and it wouldn't form properly. You had to know the exact force, the precise angle, how to work in cramped spaces, how to coordinate with your team. A master riveter was an artist. Training took years. Kaiser looked at riveting and saw an inefficient bottleneck choking production. He used welding instead, arc welding, a relatively new technique for large-scale hull construction. You could train a competent welder in 6 weeks. Not a master welder capable of the most complex joints, but good enough for most structural tasks on a cargo ship that didn't need to withstand battleship-level stresses. The old guard was horrified. Welding is inherently inferior to PARF. Riveting, they insisted with the certainty of men who'd spent decades mastering their craft. The joints are weaker. Welded ships will develop stress cracks in rough seas that riveted ships would handle easily. This is dangerous, reckless, amateurish. Men will die because of Kaiser's arrogant ignorance of proper maritime engineering. Kaiser ignored them entirely. He had his engineers run the calculations with actual metallurgical data rather than traditional assumptions. Welded joints, when properly executed, were actually stronger than riveted joints. More importantly, they were more flexible, better able to handle the stress and flex of ocean swells. The traditional shipbuilders were operating from prejudice and conventional wisdom, not rigorous engineering data. Kaiser operated exclusively from data. He hired everyone the traditional yards wouldn't touch or couldn't get. Women, African Americans, Mexican Americans, people with physical disabilities, people who'd never seen a ship before in their lives, let alone built one. At peak production, Richmond employed 90,000 workers across the 7 yards. 40,000 of them were women. Rosie the Riveter wasn't just propaganda, she was real. Her name was Rosie Monroe, a riveter from Kentucky. There was Ella Madden, who set a record with 3,000 rivets in a single shift. Wendy the welder, whose real name was Janet Doyle, became famous for producing perfect welds under impossible deadlines and demanding conditions. There were grandmothers working alongside teenagers, former schoolteachers welding beside former farmhands, housewives who'd never held industrial equipment suddenly operating cutting torches, office workers becoming crane operators. These weren't skilled maritime craftsmen with decades of inherited knowledge. They were ordinary Americans who learned one specific task and performed it repeatedly with increasing speed and precision. Kaiser treated them exactly like Henry Ford treated assembly line workers. Break complex jobs into simple, discrete steps. Train intensively on that one step until it becomes automatic. Maximize efficiency through focused repetition. Perfect one task rather than attempting to master an entire complex craft. It was pure industrial logic applied to shipbuilding. The traditionalists said it couldn't work, the mathematics said otherwise, and the mathematics were correct. The traditional shipyards watched Kaiser's construction times with growing disbelief that turned to grudging respect and eventually to alarm. 230 days became 180 days, then 120, then 90, then 60. By mid-1942, Richmond was launching a Liberty ship every 45 days on average. The old shipbuilders stopped laughing. They stopped mocking. They started paying very close attention because something genuinely impossible was happening in California. Some traditional yards tried to copy Kaiser's methods. Others clung stubbornly to their centuries of tradition. But none could match his relentless pace. Then came the competition that would create the record that stands to this day. Kaiser's Portland, Oregon yard built a ship in 10 days. An astonishing, almost unbelievable record that made headlines nationwide. Richmond Yard No. 2 took it personally. Workers and management alike wanted that record back. They pushed harder. Foremen optimized every single step of the process. Prefabrication was perfected to the minute. Crane operators practiced their precision lifts until they could place 40-ton sections with inch-perfect accuracy, while other crews were already preparing to weld them in place. November 8, 1942, Richmond Shipyard No. 2. The keel for the SS Robert E. Peary was laid at exactly 12:01 a.m. What followed was a choreographed ballet of industrial precision the world had never witnessed before. Prefabricated sections arrived on precisely calculated schedules like clockwork. They were already complete piping installed, wiring run through conduits, fixtures attached, even painted. Massive cranes swung them into position with practiced efficiency. Welders swarmed over the growing hull in coordinated shifts that never stopped. Day shift melted into night shift, melted seamlessly into day shift again. The work never paused. Meals were brought directly to workers at their stations, so they didn't waste minutes walking to and from mess halls. Inspectors followed immediately behind welders, checking every joint with X-ray equipment and visual inspection. The ship grew before the eyes of journalists, Maritime Commission officials, and competing shipyard managers who'd come to witness what they still half believed was impossible. Hour by hour, a cargo ship took shape from scattered steel sections. The Peary required 250,000 individual parts weighing approximately 14 million pounds total. Every single component had to arrive on schedule, be installed correctly, and integrate perfectly with adjacent sections. One missing bolt, one misaligned weld, one incorrectly sized pipe fitting could cascade into delays. But Kaiser's system worked with mechanical precision. Supply chains delivered materials exactly when needed. Workers knew their specific tasks so thoroughly they could execute them almost automatically. The assembly process flowed like water. 4 days, 15 hours, and 29 minutes after the keel was laid, the SS Robert E. Peary slid down the ways into San Francisco Bay, a complete functional 10,000-ton cargo ship built faster than most families could remodel a kitchen. faster than most people could build a large garden shed. Newsreels captured the launch for theatres nationwide. Journalists swarmed Kaiser, asking how it was even physically possible. "We didn't know it was impossible." Kaiser smiled that confident smile that drove traditional engineers to fury. "So we did it anyway." The record still stands today. Over 80 years later, no shipyard anywhere in the world has ever built a comparable vessel faster. Not in peacetime, not in wartime. Not with modern equipment and computer-aided design. The record is untouchable because nobody needs to build ships that fast anymore. Kaiser proved it was possible. That was enough. But here's what truly mattered to the war's outcome. The Peary wasn't a stunt. It wasn't a one-off publicity trick, though it certainly served that propaganda purpose brilliantly. It was proof of concept. Richmond Shipyard's average construction time dropped to 42 days after that demonstration. 42 days from keel to launch. Traditional yards still needed 6 months. Kaiser was building ships 5 times faster than the world's experts had confidently stated was the absolute physical limit of possibility. And he wasn't building a few demonstration vessels. He was building hundreds. By 1943, his 7 yards combined were launching 3 complete ships per day. 3 cargo vessels every single day. Do the mathematics. That's 90 ships per month. Over 1,000 ships per year from Kaiser's operations alone, and there were other yards using his methods. The numbers were staggering if you were planning Allied logistics. They were absolutely terrifying if you were coordinating German U-boat operations. Kapitän zur See Ernst Hoffmann commanded U-boat operations in the Atlantic from his headquarters in Lorient, France. His job was to coordinate the wolf packs, analyze convoy routes, direct submarines to intercept points, and maximize Allied shipping losses. He worked with maps covered in pins, intelligence reports, and mathematical projections. Every day, updates arrived. Another convoy sighted, another merchant ship torpedoed, another U-boat returning to port with empty tubes, needing weeks of resupply before it could hunt again. In 1941 and early 1942, the strategy had worked brilliantly. German U-boats were sinking Allied ships significantly faster than they could be replaced. The numbers looked genuinely encouraging from the German perspective. January 1942, 62 Allied ships sunk, 327,000 tons sent to the bottom. March 1942, 95 ships, 534,000 tons. The United States had just entered the war, and their coastal waters were essentially unprotected. U-boats operated with near impunity off New York, Florida, the Gulf of Mexico, sometimes sinking tankers within sight of American beaches while civilians watched the explosions from shore. The Americans called it the second happy time for German submariners. Hoffmann's superiors in Berlin were celebrating. The United States was losing the Battle of the Atlantic before American industrial mobilization could even begin properly. Then something changed in the numbers that Hoffmann tracked obsessively. If you find this story engaging, please take a moment to subscribe and enable notifications. It helps us continue producing in-depth content like this. By late 1942, Hoffmann noticed something deeply disturbing in the convoy intelligence reports. The convoys weren't getting smaller or less frequent. They were getting larger. His U-boats were still finding targets, still sinking ships at roughly the same rate per patrol. The individual U-boat effectiveness hadn't declined, but for every merchant vessel sent to the bottom, 3 more appeared in the next convoy sailing from American ports. Where were they coming from? The intelligence reports from the Abwehr landed on his desk in January 1943. He read them twice, then a third time, then sat motionless at his desk, doing calculations in his head. American shipyards had produced 746 new cargo vessels in 1942. Not repairs, not conversions of existing hulls, not refitted passenger ships. Brand new vessels, built from the keel upward. 746 in a single year. Hoffman knew the comparison numbers by heart because strategic planning was his specialty. Germany's entire merchant fleet at the start of the war had been 2,500 ships, accumulated over decades of normal peacetime construction. America had built a third of that total in 1 year, and the projections for 1943 were catastrophically worse from the German perspective. Expected American production: 1,200 new cargo ships, 1,200. In 1 year, Hoffman sat at his desk and performed the mathematical calculation that would haunt him for the rest of his life, and that he'd later recount to Allied interrogators. A U-boat on an exceptionally successful patrol with favorable conditions and weak convoy protection might sink 4 or 5 vessels. Then it had to return to port for weeks to rearm, resupply, repair any damage, and give the crew rest before the next patrol. The crews needed psychological recovery time as well. The stress of submarine warfare was brutal, with constant fear of depth charges, claustrophobic conditions, and the knowledge that if your boat was hit, drowning was almost certain. Germany had roughly 400 U-boats operational at any given time across all theatres: Atlantic, Mediterranean, Indian Ocean, but only a fraction could be at sea simultaneously. Others were in port refitting, or in transit, or undergoing repairs, or serving as training vessels. On average, perhaps 120 U-boats were actively hunting at any given moment. Even if every single U-boat sank 5 ships per patrol, which was wildly, absurdly optimistic, that would be 2,000 ships per year maximum. America alone was building 1,200. Britain was still building ships despite the bombing. Canada was building ships. The mathematics didn't work. Germany would need to sink more ships than America could build just to break even, just to maintain the status quo. But America was building them faster than U-boats could possibly sink them. The equation was simple, brutal, and horrifying in its finality. It wasn't even close to a fair fight. The report on the Richmond shipyards made the strategic situation exponentially worse. One facility, just one among many American yards, was building 3 ships daily. Average construction time, 42 days. Record construction time, 4 days, 15 hours, 29 minutes. It seemed like enemy propaganda designed to demoralize German forces. It seemed physically impossible. Hoffman consulted with German naval architects, showing them the intelligence data. They ran their own independent calculations, checking and rechecking the numbers. It's theoretically possible, one engineer finally admitted reluctantly, but only with massive resources. You'd need tens of thousands of workers, uninterrupted supply chains bringing steel and components, unlimited raw materials, advanced fabrication equipment. Perfect logistical coordination, and most importantly, no fear of bombing disrupting everything. Germany didn't have tens of thousands of spare workers. Every able-bodied German was already in a uniform or in a factory producing weapons. Germany didn't have uninterrupted supply chains. The Ruhr industrial region was under constant Allied bombing. Rail lines were being destroyed faster than they could be repaired. Factories were operating at partial capacity, constantly moving equipment underground to escape bombardment. Germany didn't have unlimited resources. Germany was fighting on 3 fronts. Simultaneously, the Eastern Front against the Soviets consuming men and materiel at horrifying rates, North Africa against British and American forces, and defending occupied Europe against partisan resistance and increasingly devastating Allied bombing raids. Every resource was stretched impossibly thin. American factories, by contrast, were completely untouched by war. 3,000 miles from the nearest German bomber, well beyond the range of any possible attack, they had access to unlimited steel, aluminum, rubber and copper from mines across the continent. They had a workforce of millions, including women and minorities previously excluded from industrial work, suddenly unleashed as productive capacity. They had an economy operating at full wartime capacity, with zero fear of bombing raids, no partisan sabotage, no resource shortages forcing production compromises. Hoffman's analysts created production projection curves, plotting them carefully on graph paper. The lines crossed in late 1943. By the end of that year, America would have more total cargo capacity than it had lost to U-boats since the war began, plus sufficient additional capacity to overwhelm anything Germany could possibly sink going forward. The U-boats weren't losing individual tactical battles. Many patrols were still successful. They simply couldn't win the strategic war. It was mathematical certainty, backed by industrial capacity, that Germany had no possible counter for. He drafted a careful report to Admiral Karl Dönitz, commander of the U-boat fleet, the man known as the Lion. In Nazi Germany, pessimistic military reports could be interpreted as defeatism, which was effectively a death sentence. Officers had been executed for less. Hoffman chose his words with extreme care. "Current strategy appears unsustainable," he wrote. "Enemy production capacity exceeds our destruction capacity by a factor of 3 to 1, and this disparity is increasing monthly. Recommend strategic reassessment of Atlantic operations." The report was forwarded through proper channels to Berlin, to Dönitz's headquarters. Dönitz read it and understood the implications immediately. He was a U-boat commander himself, a veteran of the Great War who'd spent time underwater. He understood tonnage, calculations, logistics, and attrition rates better than almost anyone in the German military. But what realistic options existed? The U-boat fleet was Germany's only weapon capable of striking at Allied logistics directly. To abandon the Atlantic campaign was to concede defeat, to allow unlimited supply shipments to Britain, to admit that Germany couldn't prevent American industrial might from crossing the ocean and eventually crushing the Third Reich. So they continued fighting a battle they'd mathematically already lost. Orders went out to U-boat commanders: sink more ships, target high-value tankers carrying fuel, prioritize cargo vessels over warships, accept higher risks. But the fundamental mathematics didn't change. They couldn't change. Industrial capacity was industrial capacity. You couldn't sink mathematics with torpedoes. By mid-1943, the mathematics became undeniably visible in blood and wreckage. U-boat losses spiked dramatically. Allied convoy protection had improved with terrifying effectiveness. Radar that could detect surfaced submarines in complete darkness and fog. Sonar that could track them underwater with increasing precision. Escort carriers providing constant air cover in mid-ocean areas that had previously been safe hunting grounds called the Atlantic Gap. Long-range patrol aircraft like the B-24 Liberator, closing that gap entirely. May 1943. 41 U-boats sunk in a single month, nearly 10% of the entire operational fleet destroyed in 30 days. Dönitz called it Black May, and briefly withdrew the U-boat fleet from the North Atlantic entirely to regroup and develop new tactics. But Hoffman knew the real defeat wasn't tactical. It wasn't about radar effectiveness or convoy protection or air cover, though those all mattered. The real defeat was industrial. Germany had lost an industrial war to an opponent with 10 times their production capacity and zero vulnerability to counterattack. Every U-boat took 10 months to build with skilled workers, precision engineering, and complex systems. Submarines required extraordinary manufacturing quality. Any flaw could be fatal at depth. Germany would produce 1,156 U-boats during the entire war, a monumental effort representing the largest submarine fleet in history and an enormous investment of resources. America produced 2,710 Liberty ships alone, just one class of merchant vessel, plus hundreds of victory ships, an improved design, plus tankers, plus escort carriers that hunted submarines, plus destroyer escorts, plus the ships Britain was building, plus Canada, plus Australia. The disparity was cosmic in scale. One side was fighting with metaphorical sticks and stones. The other had unlocked industrial power at a scale previously unimaginable in human history. Hoffman sat in his bunker overlooking the U-boat pens at Lorient and performed the final calculation. At current rates, by 1945, America would have 5,000 new cargo ships. Germany would have sunk perhaps 2,000 Allied vessels total across the entire war, counting all theatres. The Allies would still have more ships than they'd started with. Plus Britain's existing fleet, plus captured Italian vessels, plus captured French vessels, plus Norwegian, Dutch, and Belgian ships seized when those countries fell. The Atlantic wasn't a battle anymore. It was a slow-motion execution by mathematics, an industrial strangulation where the outcome had been determined before most of the fighting even occurred. And the man executing Germany through superior logistics had never built a ship before 1940. The dam builder had defeated the German Navy. The final numbers tell the complete, merciless story. Kaiser's 7 shipyards produced 1,490 vessels during World War II, 27% of all ships ordered by the US. Maritime Commission. Total American Liberty ship production across all yards using his revolutionary methods. 2,710 vessels. Overall cargo ships of all types across all wartime programs. 5,777 vessels. Plus hundreds of warships, escort carriers that hunted U-boats, and destroyers that protected convoys. The entire Liberty ship program cost $13 billion in 1940s currency, roughly $200 billion in today's money when adjusted for inflation. It was the most expensive single industrial program in human history at that point, dwarfing even the Manhattan Project's cost. But it worked with devastating effectiveness. By 1944, Allied shipping tonnage exceeded pre-war levels despite 4 continuous years of losses to submarines, mines, surface raiders, and aircraft. The U-boat threat was contained, not defeated through superior naval tactics or better convoy strategies, but defeated through superior mathematics. Germany simply couldn't sink ships fast enough to matter anymore. Traditional shipbuilders had insisted Kaiser's methods would fail catastrophically. They were wrong about almost everything. Welded ships proved more durable than riveted ones in most conditions. The flexible welded joints actually handled stress and flex better than rigid rivets, contrary to centuries of maritime conventional wisdom. Yes, some Liberty ships did experience catastrophic brittle fracture failures. In cold water ships literally broke in half, but these were design flaws that were quickly corrected, not fundamental failures of welding technology. Of the 2,710 Liberty ships built, only 200 were lost to enemy action, less than 8% losses. That's an extraordinary survival rate for merchant vessels operating in wartime conditions in submarine-infested waters. Assembly line production delivered consistent quality at unprecedented scale. Workers, trained in weeks, performed as well as craftsmen trained for years on the specific tasks that mattered for wartime construction. The amateurs had revolutionized an ancient industry that had resisted significant change for centuries. After the war, global shipbuilding adopted Kaiser's methods wholesale. Japan built their entire post-war shipping industry on assembly line principles learned from studying American wartime construction. South Korea did the same decades later when building their shipbuilding industry. Modern shipyards from China to Finland use prefabrication and modular construction as standard practice worldwide. The techniques Kaiser pioneered in Richmond between 1940 and 1945 are now simply how ships are built everywhere. The revolutionary became ordinary, the impossible became standard procedure. 2 Liberty ships still exist as operating museums. The SS John W. Brown in Baltimore, Maryland. The SS Jeremiah O'Brien in San Francisco, California. Both occasionally go to sea, maintained by dedicated volunteers. 80 years old and still functional. They could still make the crossing to Europe if absolutely needed, though they'd be painfully slow by modern standards. A living testament to the structural quality of Kaiser's supposedly inferior mass-produced vessels. The ships the experts confidently predicted would crack and sink have outlasted nearly all of their critics. Henry Kaiser went on to an extraordinary post-war career that proved his wartime success wasn't a lucky fluke. He founded Kaiser Permanente, one of America's largest healthcare systems, applying the same organizational principles make quality services accessible through efficient systems and massive scale. He built Kaiser Aluminum, Kaiser Steel, Kaiser Cement. Everything he touched seemed to turn to industrial gold. But his greatest achievement remained those ships, and what they proved about innovation, determination, and the power of questioning conventional and wisdom. He'd proven a fundamental truth about innovation that resonates far beyond shipbuilding. Unconventional thinking could defeat conventional wisdom when backed by rigorous engineering and relentless execution. An outsider could revolutionize an established industry precisely because he wasn't imprisoned by its traditional assumptions and rules that weren't really rules at all. Assembly line principles, properly applied with intelligent adaptation, could work on anything, even complex products like ships that had been built essentially the same way for thousands of years. For Ernst Hoffmann, the war ended in defeat, exactly as he'd predicted in 1943 when he first read those impossible production numbers. He survived, which was more than most U-boat officers could claim. 30,000 German submariners died during the war, 75% of all men who served in U-boats, the highest casualty rate of any military service in any nation. Hoffmann was interrogated by Allied naval intelligence officers in 1945. They were particularly interested in when German command had known they'd lost the Atlantic. "When did you realize?" an American officer asked directly. Hoffmann thought for a long moment, remembering the intelligence reports, the impossible numbers, the calculations that refused to work no matter how many times he ran them. He finally said, "When we realized American production had exceeded our ability to sink ships. The intelligence reports on your shipyards, the Liberty ship program specifically, that was when we knew with absolute certainty. Everything after was just mathematics playing out. We were fighting an equation we couldn't solve." The American officer nodded, taking careful notes. "What would you have done differently with hindsight?" Hoffmann laughed bitterly, a hollow sound without humor. "Differently?" There was nothing to do differently. You can't fight industrial capacity with willpower alone. You can't sink mathematics with torpedoes. We lost the moment your Henry Kaiser figured out how to build ships like automobiles. The rest was inevitable. We were doomed from the moment he started welding instead of riveting. The Battle of the Atlantic killed 72,200 Allied sailors and merchant mariners. 30,000 German U-boat crew died in their steel coffins beneath the waves. Thousands of ships went to the bottom. The ocean floor from the Gulf of Mexico to the Norwegian Sea is permanently littered with wrecks from that brutal struggle. But the ultimate outcome was decided not primarily by those battles, not by tactical brilliance or individual courage, but in Richmond, California, where workers who'd never seen the ocean built ships faster than anyone thought humanly possible. Where a dam builder looked at centuries of tradition and asked one devastatingly simple question: why? And where the answer to that question changed the course of history and demonstrated that in industrial warfare, innovation and production capacity matter more than traditional excellence. The SS Robert E. Peary, the ship built in 4 days and 15 hours, made 6 successful wartime voyages. She carried 11,000 tons of cargo to Mediterranean and Pacific theaters, surviving dangerous waters where many sister ships were lost. She survived the war without serious damage, which was itself remarkable given the casualty rates. She was finally scrapped in 1963, 21 years after her record-breaking launch, having served well beyond her original 5-year design life. The record she set on November 12, 1942, will likely never be broken, not because modern shipyards couldn't replicate it with current technology and computer-aided design, but because nobody needs to. Henry Kaiser proved it was possible. That was sufficient. The point was made. And in proving it was possible, he proved something far more important than a construction record. In industrial total warfare, innovation matters more than tradition. Speed matters more than individual perfection. Volume matters more than artisanal quality, and sometimes the absolute best person to revolutionize an industry is someone who doesn't know the rules, who doesn't respect the conventional wisdom, who doesn't understand why something supposedly can't be done. Someone who looks at impossible and sees merely a challenge instead of an insurmountable barrier. Someone who asks, why not, when everyone else says, because that's how it's always been done. Kaiser was that person. His ships won a war through logistics rather than firepower. His methods changed a global industry forever. And his legacy is every cargo ship sailing every ocean today, built using techniques he pioneered, in yards organized using principles he established, by workers trained using methods he invented and proved effective, under the most demanding conditions imaginable. The amateur who revolutionized shipbuilding, the outsider who defeated centuries of maritime tradition, the dam builder who asked why and changed everything about how humanity builds ships. The Liberty ships weren't just cargo vessels carrying supplies. They were proof that in total war, the factory matters as much as the battlefield, that civilians with determination and systematic thinking can achieve what credentialed experts declare physically impossible. That innovation always eventually defeats tradition when backed by rigorous engineering and willingness to challenge assumptions. And that sometimes the most powerful weapon in total war isn't a bomb or a bullet or a torpedo. It's asking why not and systematically refusing to accept, because that's how we've always done it, as a legitimate answer to engineering problems that can be solved through logic and pites. Determination. Henry Kaiser asked that question in 1940. His answer buried the Third Reich under an avalanche of welded steel that crossed the Atlantic faster than U-boats could sink it. Mathematics defeated tradition. Industry defeated military might. Production defeated tactics. And a man who'd never built a ship proved that sometimes ignorance of limitations is the greatest competitive advantage possible, because it allows you to attempt what experts know cannot be done. Thank you for watching. For more detailed historical breakdowns, check out the other videos on your screen now, and don't forget to subscribe.